Hello, welcome to our lesson. We're going to be doing 4.4 today. We are going to be factoring trig functions. So before we factor trig functions, first we should remember how to factor. So if I want to factor this, and let's set this equal to 0 and solve for the values of x also. So the first thing we do is we can factor out an x. So now we have 3x minus 2. Now if we set that equal to 0, now what we have to do is take both of these sections and set them equal to 0, because 0 times 0 would give you 0. So this first equation is easy, x equals 0. The second one, we have 3x minus 2 equals 0. Now I can add 2, and so 3x equals 2. Then if I divide by 3, x is equal to 2/3. So if I have an equation like this, there's two answers. X can be 0 or 2/3. Now if we have something like this is really similar to the previous problem. We just have to make the right side equal 0. So I do that by subtracting 8x on both sides. Now from here I can factor out a 2x, leaving x minus 4. Now if I set 2x equal to 0 and x minus 4 equal to 0, I can find my values for x. If I divide by 2, my x is 0. Here I add 4. 0 plus 4 is 4. So my x values are 0 and 4. Now we get a little trickier because we're getting into trinomials. There's a couple ways we can do this one. We can guess and check, or that one's not very fun to watch me do it. So if you don't want to guess and check, we can split the middle term. Now splitting the middle term, we have to multiply the first coefficient with the last to get negative 2. What numbers multiply to negative 2 but add up to this coefficient, which is negative 1? Well, it would be negative 1 plus, or negative 2 plus 1. So we split that middle term up using these two numbers, minus 2x plus 1x. And then this last term is just minus 1. If I divide this down the middle, 2x squared minus 2x, I can take a 2x out of both of those, leaving x minus 1. Now I can't take anything out of that, so the only thing I'll take to the outside is 1. Now I can, since x minus 1 and x minus 1 are the same values, I can pull them to the outside of the equation. So I have x minus 1, leaving 2x plus 1 left over. Now if I have 2 sine squared minus sine theta minus 1 equals 0. Oh, one thing I should have done here is put this equal to 0, just so we can solve this one with two separate equations. If we did that, it would be x minus 1 is equal to 0, and then 2x plus 1 is equal to 0. Now if we do that, add 1 to both sides, so x is going to be 1. Here we subtract 1. 2x equals negative 1. X is going to be negative 1/2. So my x value is negative 1/2 and 1. All right, so we've already seen the previous problem. It looks a lot like this. 2 sine squared minus sine theta minus 1. We do the same thing that we would do if we had 2x squared minus x minus 1. So if it helps you, convert your signs to x's, do your factoring to this. So x minus 1, 2x plus 1, and then put in our x equals sign. So it would be sine of theta minus 1, 2 sine of theta plus 1 equals 0. So now what we do is we want to separate this into two groups. One of them, we say sine of theta minus 1 equals 0. And over here we say 2 sine of theta plus 1 equals 0. We want to solve each of these independently. So here I add 1 to both sides, so I have sine of theta equals 1. I take the arc sine to get rid of the sine, so theta is equal to the arc sine of 1. the arcsine of 1 is going to be split into two equations where I have the inverse sine of 1 plus 360n, and then theta is also 180 minus the inverse sine of 1 plus 360n. Now the inverse sine of 1, there's many different ways you can do it. One way you can do is the principal branches here. When is the value equal 1? That's at 90 degrees. So theta is going to equal 90 plus 360n. And over here we have 180 minus 90, which is also 90 plus 360n. So this part we don't actually need because it brings us to the same solution. All right, let's work on this one over here. I'll do it in red just to separate it. I subtract 1, so I have 2 sine of theta equals negative 1. Divide by 2. 2 sine of theta equals negative 1/2. I take the arcsine of both sides, so theta is the arcsine of negative 1/2. And let's bring this down as far as we can. So I have theta is equal to the inverse sine of negative 1/2 plus 360n. And I have theta equals 180 minus the inverse sine of negative 1/2 plus 360n. I'm running out of room on the right-hand side there, so I had to kind of shorten it there. The inverse sine of negative 1/2, negative 1/2 would be down here, so that would be a negative 30 degrees. And over here, 180 minus a negative 30 is going to be, minus a negative is addition, so 210 plus 360n. So we have three values, 1, 2, 3 equations for our general solution. Now with these three solutions, 90 plus 360n, negative 30 plus 360n, and 210 plus 360n. Now let's see all of the values. Let's solve for the values between negative 360 and 360. If we just take this first one, we know theta is going to be equal 90. If I add 360 to it, it will be 450, and that's above 360, so that would be out of our set of values here. If I subtract 360, so if n equals negative 1, negative 1 times 360 is negative 360, so 90 minus 360 is going to be a negative 270, and that is in this range. If I go to this set of the values, I know negative 30 works. If I subtract 360, it will go too low, but if I add 360, I'd get 330. If I add another 360, it would be over. Now 210, we know that works. If I add 360, that'll be over. If I subtract 360, that would be negative 150. So if I wrote these in order, I would have negative 270, negative 150, negative 30, 90, 210, and 330. These are all the values that will work for theta in that given equation. If it helps you, think of this as x squared minus 2x minus 3. And if I factor that, that would be x minus 3, x plus 1. So if I factored it using cosine, that would be cosine of theta minus 3 and cosine of theta plus 1. So now I have to separate these into two equations where I have cosine of theta minus 3 equals 0, cosine of theta plus 1 equals 0. If I add 3 on both sides, I have cosine of theta equals 3, take the arc cosine of 3. Now, even right at this point, you should see that this is an empty set because cosine of theta is always between negative 1 and 1. Over here, if I subtract 1 on both sides, I have the cosine of theta equaling negative 1. So theta is equal to the arc cosine of negative 1. So theta is plus or minus the inverse cosine of negative 1 plus 360n. Now the inverse cosine of negative 1, if we think about the principal branch of cosine being between 0 and 180, it hits negative 1 at 180 degrees. So this is going to be plus or minus 180 degrees plus 360n. And that's my general solution. So now if I want to find the values for theta between negative 360 and 360 using this equation, now I know positive 180 works, and I know negative 180 works. And if I add 360 to 180, it goes over. If I subtract 360 from 180, it gets to negative 180. If I subtract 360 again, it goes under. So these are the only values that will work for theta for this problem. All right. So if we have an equation like this, this is similar to x squared minus, or x squared equals 1/2 x. I subtract that from both sides. So I have x squared minus 1/2 x. Factor out an x. So it would be x times x minus 1/2. That equals 0, I should say. So to do this, what we're going to do is, all right, so if we put sine in for x, so we have sine of theta, parentheses, sine of theta minus 1/2 is equal to 0. We set these into two equations where we have sine of theta is equal to 0, and then we have sine of theta minus 1/2 is equal to 0. So I take the arc sine of both sides, so theta is the arc sine of 0. The arc sine of 0 has theta equals the inverse sine of 0 plus 360n. It also has theta is equal to 180 minus the inverse sine of 0 plus 360n. Now the inverse sine of 0, if we think about inverse sine being from its principal branch of sine is from negative 90 to 90, 0 is going to be the inverse sine of 0. So that's going to be 0 plus 360n. 180 minus 0 is just going to be 180 plus 360n. All right, so let's change the color up and work on this one below. So if I add 1/2 to both sides, I have the sine of theta equals 1/2. Take the arc sine of both sides, so theta equals the arc sine of 1/2, which gives us theta is the inverse sine of 1/2 plus 360n, and theta equals 180 minus the inverse sine of 1/2 plus 360n. Now the inverse sine of 1/2, that's going to be 1 over 2. That's 30 degrees. And 180 minus 30 degrees is 150. So we have 4 general solutions. 1, 2, 3, 4. All right. I'm hoping this makes sense to you. So now if I want to take all 4 of these solutions and I want to find the values for theta between negative 360 and 360, Well, these brackets actually matter in this particular problem because in this situation, 0 would work. If I add 360, 360 would work. If I subtract 360, negative 360 would work. And then remember, those brackets mean it includes the top and the bottom, the negative 360 and 360. Now, 180 is within that range. If I add 360, it's too much, but if I subtract 360, it would get down to negative 180. Now for 30, I can't add 360, but I can subtract 360 to get negative 330. And I shouldn't forget my 30. Also, 150 works. I can't add 360, but if I subtract 360, that would be negative 210. So again, if I put that in order, we'd go negative 360, negative 330, negative 210, negative 180. I should cross these out as I go along here. Then it hits 0, 30, 150, 180, and 360. Those are all the values of theta that will work between negative 360 and 360.